So this video is the part 2 of the video in which we were solving questions on the motion of connected bodies. There we have done 5 questions and the remaining questions we are continuing in this video. So let's start with the question number 6. In question number 6, there is an Atwood machine. This is shown in the figure. The system is known as Atwood machine and it starts from rest. So we have to find the speed and the distance moved by each mass at t is equal to 3 seconds. If it starts from rest, then at t is equal to 3 seconds पे each mass will move to some distance with some speed. That speed and distance we have to calculate. So let's start doing this. So we solve the question from our technique. That means we will write force equations for both the blocks. First, for the 10 kg block I am writing. So the tension that is acting on this strings will be because of this point of contact. So these are the tension T and T, and the weight of the blocks are acting downwards. That means mg means 10g and this one is 12g. Now when it starts moving, the lighter weight will move upwards and the heavier will go downwards. So if a is the acceleration, then from acceleration a, this block of 12 kg will move downward, and from acceleration a, this block of 10 kilograms will move upwards. These are all the forces that are acting on these blocks. Now we are going to write force equations. So first I am writing it for 10 kg block. For this one, net force will be mass into acceleration, that is 10a, but this net force is equal to the difference of tension and weight, right? Since the motion is upwards, this shows that the upward tension is more than the downward weight. So we have to write net force is equal to T minus 10g, which is equal to 10a. This is equation number 1 for the block of 10 kilogram. Now for the block of 12 kilogram, the net force is 12a, that is mass into acceleration, but this net force according to the diagram is equal to the difference between T and 12g, where the body is moving downwards, which shows that 12g is more than T. So we have to write 12g minus T is equal to 12a. This is equation number 2. Now to find acceleration, simply add these equations and you will get the answer. Add 1 and 2 and we get T minus 10g plus 12g minus 10. This is the left side is equal to, this is 10a. 10a plus 12a. So we get, tension will cancel out and we get the answer 2g is equal to 22a, which is equal to, which implies that acceleration is equal to 2g upon 22, or 2 into 9.8 upon 22 is equal to 9.8 into upon 11, and this will give you the answer 0.89 meter per second square. So the answer for acceleration is 0.89 meter per second square. Now in question we have to find the speed and distance for the time 3 seconds. So now we are going to use equation of motion. So from first equation of motion, v is equal to u plus at. We know that initially they were at rest, the objects were at rest. So finally the speed will be v is equal to 0 plus acceleration is 0.89 and the time is 3 seconds, that is given in the question. So the final speed that we get is 2.67 meter per second. Similarly, using second equation of motion, we can find the distance moved, s is equal to ut plus half at square, and solving this we get the distance moved is equal to, this u is equal to 0, so it will be 0 plus half, acceleration is 0.89 and t square is 3 square. So s is equal to half into 0.89 into 9, which gives the answer. This answer will be approximately is equal to 4 meter. So these are the required answers that were asked in the question, and that's how we'll do. Same concept हमें use करना है. We have to write force equations and then solve those equations for acceleration or tension, whatever is needed. Okay, let's move to question number 7. Question number 7 states that there is a body of mass m1 and that value is 10 kilograms. So m1 is 10 kilograms. This is given. It is placed on a smooth horizontal table, means frictionless surface. It is connected to a string which passes over a frictionless pulley. The pulley here is also frictionless and carries at the other end a body of mass m2. At the other end of it there is a body of mass m2 which is of 5 kilogram, right? So the mass of the second body is 5 kilogram. Now we have to find the acceleration that will be produced in the bodies when nail fixed to the table is removed. Means these were fixed, this is fixed, but जैसे ही we remove the nail it starts moving like this. It will move towards right and this will move towards downwards. So we have to find the acceleration A that is produced in the bodies when the nail fixed to the table is removed. Next thing, we have to find the tension in the string during the motion of the bodies. First we want to find the acceleration, then we want to find the tension in the string. So tension in the string is because of the point of contact. This is T and here it is also T. We have to find T. And what when the bodies stop? So we also want to find the tension in the string when these bodies stop, means when acceleration becomes 0, then we also find the tension. We want to find tension in two cases. First, when the bodies were moving during the motion of the bodies, and then when the bodies stop. So first we will find it for general case and then we will put A is equal to 0 for stationary case. Let's start. So as we do, we will start with writing force equation. For that we have need the free body diagram of this system, or we have to mark all the forces acting on this object. So here the weight is acting, that is m2g. Also here weight is acting, that is m1g, but normally to it there is a reaction also, that is r. So these are balanced, so there is no need for considering these forces in calculation. We only need tension and the accelerating forces. Now let's start with the writing force equation for both the objects. Let's start for the first one. इस object, इस वाले block के लिए I am writing force equation. So the net force acting on this block, these two will cancel out. Then the net force on the block first will be mass into acceleration, that is m1a, and as per the diagram the force, that is the reason behind this force, is the tension capital T. So F net is T is equal to m1a. This is equation number 1. Now for the block second, since in block second these two forces are acting, m2g downwards, T upwards, so the resultant is the difference of these two, but the resultant force is in downward direction. That shows this m2g is more than T. So net force is equal to m2a, and this net force is equal to the difference of m2g minus T is equal to m2a, or we can write T is equal to m2g minus m2a or m2g minus a. This is equation number 2. Basically I want to eliminate T, that so that I can find acceleration. So from equation number 1 and 2 I am going to eliminate T. For that I am going to equate these two equations. From 1 and 2 I can write m1a is equal to m2g minus m2a, and on solving, putting it here, I can get m1 plus m2a is equal to m2g, or the acceleration A is equal to m2 upon m1 plus m2g. We know all the values, so we can substitute these values and can find the answer 5 upon 10 plus 5, and g we are using 9.8. So we get the answer 5 upon 15 into 9.8, that is 3.27 meter per second square. For acceleration the unit is meter per second square. Now after acceleration we want the tension T, so we can substitute the value of A in equation number 1 to get the value of T. T is equal to m1a, that means 10 into 3.27, that is 32.7 Newton. So this was the case when bodies were moving, are in motion. For stationary case, we have to put A is equal to 0. For stationary case, A is equal to 0. That means this object will not move. A is equal to 0. This will not move. Tension यहाँ पर बिल्कुल भी खत्म हो जाएगा. But here at the second object, M2G is still acting. So from equation number 2, if we put A is equal to 0, still T is equal to M2G is there. So the tension T is equal to M2G, means there is force acting on this object also. There is tension acting on this object, but not because of this acceleration, but because of the weight of M2 only. इस M2G की वजह से हमें यहाँ पर टेंशन अभी भी मिलेगा, बट एक्सेलरेशन नहीं होगा. So this T is equal to M2G and the value for it will be 5 into 9.8 and the answer is 49 Newton. So this is the answer for the tension when net force on each body is 0, or we can say that there is no motion of bodies. Since there is no motion of bodies, that's why these forces are balanced. ऐसे भी बोल सकते हैं हम. We can also say it like this. There is no motion of bodies, means all the forces are balanced. That means T is equal to M2G. So tension is equal to M2G and it is equal to 49 Newton. That's all for the question. Moving to the next one. So in question number 8, we have this diagram and we have to find the acceleration of both blocks of mass m1 and m2 in terms of m1, m2 and g. So basically we want to find the acceleration of both blocks, right? So first of all, they are asking for acceleration of both blocks. That means in this case, the acceleration of both blocks is not going to be same. This is the very first point. Now the reason is that if we are pulling this block by 10 meters, that means this pulley is going upward. If I am pulling it by 10 meters, this pulley is going upwards, but this is a single rope, right? So single rope ka meaning hai that this rope is pulled by a distance of or by a length of 10 meter, but here it is divided into two sections. So 5 meter from this and 5 meter from this will be reduced. So it will go upward by 5 meter only. That means if we pull this section by x meters, then this pulley will move upward by x by 2 only. So if this object has acceleration a, then this object will have acceleration a by 2. This is the point that we have to note in this question. Similarly, instead of pulling, if I say that this m1 mass is moving x distance towards right, then this m2 mass move downwards by a distance x by 2 only, because the section that is coming here of the rope, it get divided into two strands, like half either, half either. That's why the net distance that is moved downward by the m2 is x by 2. So this point we have to note. If m1 moves toward right by length x, then m2 move downward by x by 2, and the reason is that this rope is divided into two sections na. So x agar idhar aayega to it will be x by 2 in this and x by 2 in this. Because of this, the acceleration of m1, if the acceleration of m1 is a, then acceleration of m2 will be a by 2. So basically we have to find a single acceleration. After that we will have it to get the acceleration of m2. So let's see what are the forces acting here. At this point of contact there is a tension T1. Also at this point of contact this rope is same, this rope is same, so this will also be T1 at this point of contact and at this point of contact. These are the T1 tension. Now this is a different section of rope, so यहाँ पर the tension will be changed and it will be T2, and because of this point of contact its direction is this, it is away from the point of contact. So these are the tensions that are acting. Now we are going to write equations of forces, and the acceleration that is acting here is like this. If it is moving right, it is moving downward by the acceleration of a by 2. So let's start with the equations. For this block M1, I can write net force is equal to M1A, and the only force acting on it is T1, which implies T1 is equal to M1A. This is equation number 1. Now for the second block, this one, we have weight of it is acting downwards, that is M2G. So the net force acting on it is M2G minus T2, since it is moving downwards, which shows that this M2G is greater than T2. So we know that F net is equal to M2 and acceleration is A by 2. So this is net force is equal to M2G minus T2 is equal to M2A by 2, and on solving this we can get 2M2G minus 2T2 is equal to M2A. This is equation number 2. Now there are 3 moving objects instead of 2, because if this object is going here towards right, this M2 as well as this pulley both are coming downwards. So we write 2 equations, one for this and one for this. Still the equation for this pulley is pending. So if we write equation for this, then the net force acting on this pulley, the net force acting on this pulley will be the mass of pulley into acceleration of it, that is A by 2, and the net force acting on it is twice of T1 upwards, and this T2 is also upwards because of this point of contact, but iska is point of contact pe it will be in the downward direction. Equal and opposite tension will act in this rope at the point of contact with pulley, that means away from the pulley. So we have 2T1 in upwards direction and T2 in downwards direction at this point. Pulley per we have two forces, 2T1 going upward, and at pulley we have T2 going downwards. So the net force acting on the pulley is 2T1 and T2 ka difference. Now 2T1 is upwards, T2 is downwards, and the net motion of pulley is towards downwards, which shows that T2 is more than twice of T1, which is equal to mass of pulley into A by 2. But we have considered pulley as massless, frictionless, so this mass of pulley is 0. That means this whole right side will be 0, or we can write T2 is equal to 2T1. So this is equation number 3rd, and T1 we know the value of T1 is M1A, that means T2 is equal to twice of M1A. T2 is equal to twice of M1A. We are going to substitute this here in this equation. By putting, we can get the value of A. So we get from equation number 2, 2M2G into minus 2T2. 2T2 means 4M1A is equal to M2A. On solving this, we get acceleration is equal to 2M2G upon 4M1 plus M2. By rearranging this, we get the value of acceleration is 2M2G upon 4M1 plus M2. This is the acceleration for block of mass M1. Now for M2 block, it will be the half of A, that means A by 2. So it will be M2G upon 4M1 plus M2. So these are the required answer that we need. Moving to question number 9th. So question number 9 states that we have a block of mass 100 kilogram. This is a block of mass 100 kilogram which is set into motion. It is moving on a frictionless horizontal surface with the help of this frictionless pulley and a rope, right? So there must be a tension at this point of contact. So let's mark these tensions T and T. Now we have to find the horizontal force that should be applied on that block to produce an acceleration of 10 centimeter per second. So we know the acceleration, that is 10 centimeter per second square, or we can write it as 10 upon 100 meter per second square, or 0.1 meter per second square. I've converted into SI system. So the acceleration is given, that is 0.1 मीटर पर सेकेंड स्क्वायर, एंड फॉर दिस एक्सेलरेशन यहाँ हमें कितना फोर्स नीडेड होगा, दैट फोर्स वी वांट टू फाइंड. Okay, so this force will act on both the sections of the pulley, like here as well as here. The force will act at both the sections of the pulley. So from force equation we can write this 2F is equal to T. The forces acting on this pulley are such that the tension T towards right and 2F towards left. So these should be equal and opposite from Newton's third law. So we can write T is equal to 2F. And if we write the force equation for this block, right, of mass m, although the mass is given, I am taking is m. So for this block of mass m, the force equation or the net force will be ma, which is equal to T, because the only force is acting here is T. That means T is equal to ma, but T is also equal to 2F. So we can equate these two. That means 2F is equal to ma, or F is equal to ma upon 2, where mass is 100 kilograms, acceleration is 0.1 meter per second square, and 2. So it will be 50 into 0.1 or 5 Newton. This is the required answer. So we write force equations for pulley as well as for block separately, and then we solve the 2, and we get answer for force is equal to 5 Newton. Moving to the last question of this video, that is question number 10. According to question number 10, there are 3 bodies A, B and C, each of mass m, hanging on a string over a fixed pulley as shown in the diagram. Now what are the tensions in the strings connecting the bodies? So this is the same rope till there, right? So यहाँ पर अगर tension होगा T1, then the tension here is also T1, but in this section it will be changed and it will be T2. So now we have to find the tensions T1 and T2, right? So वही काम हमें करना है with the same concept. We will write force equation for all the 3 masses and then solve those equations to find acceleration and then T. So for the block A, it is moving upwards with acceleration A. So the net force for it is ma towards upward, and the forces acting on it are mg and T1. So we can write the net force as T1 minus mg is equal to ma. This is equation number 1, right? Moving to the block B. For block B, the acceleration is downwards, as well as for block C it is also downwards. So I am directly writing equation for T2, that means for block C. Now the motion of block C is towards downward with acceleration of A. So net force for the C block is ma, and the forces acting on it are its weight mg, like this, its weight mg downwards, and the tension T2. So we can write this net force is equal to the difference of these two forces, but the motion is downwards, that shows mg is greater than T2. So we have to write mg minus T2 is equal to ma, or T2 is equal to, this is ma, mg minus T2 is equal to ma. F net को हमने mg minus T2 रखा है, and T2 will be, by rearranging we get mg minus ma. This is equation number 2. Equation number 1 was for block A, this was for block B. For C, this was for C. We also have to write equation for block B to solve this question. So for B, if we talk about B, this T1, so this is not the only mass of block B that on which this T1 is acting. This T1 acts on the both objects, means the mass for it will be twice of m. So if we write equation for this T1, we have to consider the system of B and C. Okay, so for this, net force will be twice of m into acceleration A, and it is going downwards. So net force will be difference of T1 and the weight of these two, and the weight of these two will be more than T1 because the motion is downwards. That means net force will be 2mg, means mg for this and mg for this, minus T1 is equal to twice of ma. So from this we can write T1 is equal to 2mg minus 2ma. This is equation number 3. This third equation we have write for B plus C, a system of B plus C. Now we can solve these three equations to find the tension and acceleration. Since from these two equations we can't find the three variables. Here in these two equations we have three variables T1, T2 and A. So to solve three variables we need three equations. That's why we write the three equations. Now we are going to solve. For solving this, we are equating equation number 1 and 3, or we can say that we are substituting the value of T1 from 3 to 1. From 1 and 3, we are substituting the value of T1 to equation number 1. So we get 2mg minus 2ma minus mg is equal to ma, and we are solving it. So 2mg minus mg is mg is equal to ma plus 2ma, that will be 3ma, and acceleration we get from here will be mg upon 3m, that means g upon 3. So this is the acceleration we get. Now we can find tension by substituting the value of a. So we are substituting this value in equation number 1 to get the value of T1. So T1 is equal to minus mg, T1 minus mg is equal to ma, that means T1 is equal to ma plus mg. T1 is equal to ma plus mg is equal to m g by 3 plus g, and on solving this we get 4g upon 3. That means tension will be 4 upon 3 mg. This is tension 1. Now for 2T2 we are using the equation number 2 and going to substitute the value of acceleration in this equation. So T2 is equal to mg minus ma. T2 is equal to mg minus ma, where a is g by 3. On solving this we get T2 is equal to m, 3g minus g is 2g by 3. So 2 by 3 mg is the tension for second part of the string. Okay, so T2 is 2 upon 3 mg, T1 is 4 upon 3 mg, and acceleration was g upon 3. These are the required answer. We write three equations because we need three variables T1, T2 and A. If some of the variable is given, like if we had only two variables to find, then two equations will be enough. So that's all for the video. I guess we cover all type of questions on this topic. For further videos, stay tuned and keep studying. Thank you.